slightly different answers also. But
It's the only one with two nonmetals.
yeah, that's what you're looking for with covalent compounds, just like with the naming, two nonmetals. All right. NaHSO4. Sodium hydrogen sulfite. So you know sodium, of course, for the Na. Then you have to know what that ion is. HSO3 minus is hydrogen sulfite. Now, that may not have been one on the list, so you have to figure out that the sulfite comes from the sulfate. If you have one fewer oxygen than HSO4, which is hydrogen sulfate, which was one that you should know, you can find hydrogen sulfite. All right, a formula, shouldn't really be a structure, it should be a formula for sodium perchlorate. So that is NaClO4. So you had to know that perchlorate is the ClO4 minus anion. TiCO3 is titanium carbonate. It's got to be the 2. It's got to be titanium 2 carbonate because titanium is one of the elements in the middle that can have a variable charge. This one, you may have had any number of ones from 2A. It randomizes a little bit. But Ba3PO4 is barium phosphate. And in this case, it is important, although it wasn't an answer here, so they kind of gave you a hint that you do not use the number because barium is one that always has the same charge, which is +2. So that one, this could have been a trickier question if I had added the answer barium 2 phosphate, and you would have had to know that you leave the 2 out because it doesn't have a variable charge. Aluminum sulfate is Al2SO4 And then K2SO4, we have to decide, is that an ionic compound? What's going on here? It is ionic because it's got potassium metal with sulfate ions. So when that is in solution, that solid compound, not in solution, the solid compound contains potassium ions and sulfate ions. Right? It does not have individual atom molecules. It does not have K2SO4 molecules, because molecule is a word that we use for covalent compounds. Rather, it has those ions, K plus and SO4 minus 2 or 2 minus. PBr3 should be phosphorus tribromide, all nonmetals, so that's a covalent compound. And ClO2 dichlorine monoxide, again, not an ionic compound, so we don't use these kinds of names. We use that kind of name. All right, aluminum metal reacts with aqueous iron 2 chloride to form aqueous aluminum chloride and iron metal. So we have to make a balanced equation here. To figure out, let's use one of these extra blank pages here. So we've got aluminum metal. Uh-oh. Pen thing broken today? We'll deal with that later. We'll do it on the board. So we've got aluminum metal, Al, solid, plus aqueous iron chloride. Yields aqueous aluminum chloride and iron metal. That is not balanced as it is, so we need to have 3 here, 2 here, 2 here, 3 there. That works, right? That looks good. So what is the coefficient for aluminum? Should be 2. Yeah, 2. So to get a question like that right, it's not just about balancing equations, it's also about understanding how to write the formulas properly. Because if you didn't write the correct formulas, they'd balance in different ways and you'd get a different coefficient. All right, and then writing the balanced equation. Again, you have to get the correct formulas, in this case, as well as the phases. It didn't take off points if you got the equation right, but you got the phases in there wrong, as long as you got the equation right. You did lose points if you got other stuff wrong, but it didn't give you the full correct answer until you added the phases as well. In this case, it told you that it forms solid hydroxide. I told you. Today we're going to talk about how we figure that out when it doesn't tell you. And then finally, what's the order of decreasing mass percent composition for C3H2N without doing the calculations? Now, of course, if you couldn't figure out how to do this, you could just do the calculations and you get it that way. But how would you figure this out without doing the without actually calculating mass percent for C, H, and N? Why does it say that you shouldn't need to do that, or you may not need to do that? Yeah.
Because carbon and nitrogen are relatively close in mass, so since you have 3 carbons, it's going to be higher than the nitrogen. And since hydrogen only has 1, so it would be C first, and then H, because 2 is going to be less than 14.
Right. Right. So C, N, and H, because you can see here that we know C and N are right next to each other, so they're only off by a couple. And if there's 3 carbons for every 1 nitrogen, it's going to be much higher mass percent of carbon, as you said. And then, of course, hydrogen has a much, much smaller mass, so that would be the lowest. All right, good quiz. So, let's see if I can fix this N thing that doesn't seem to want to. I can end some of these services and restart it. We'll see if it does anything. Otherwise, we'll go back to the chalkboard for today. I don't see that little thing that's usually up here either. Okay, that's fine. We'll go back to the chalkboard for now. So let me close this stuff out. I'm just going to restart this and see if that does it. And while we do that, let's talk